Alright, hello everyone. Welcome to our today's lesson on exponent laws. Right, so following our BEDMAS, right, we're gonna learn about how we can use signs to manipulate exponents. Right, so let's just start with an example of a garden. Right, let's say for the garden we have our length and width and want to find the area of said garden. And of course, we just have to remember the area, right, is just length times width. And to illustrate exponent laws, let's use exponents so we can really clearly see what we are doing here. So let's say the length of the plot of the garden is 2 squared, right? Which is 2 times 2, which is 4. And the width of the garden is 2 cubed. So 2 times 2 times 2. Remember, it is 2 times 2 times 2, not 2 times 3. Right? Very different. So now what's the area of this garden? Now the area of this garden is just length times width. Okay, so it's the 2 squared times the 3 cubed, which is just 2 times 2, and then 2 times 2 times 2, which is 32. Right, 4 times 8, which is 32. And we notice here that 32 is 2 to the power 5, right? As you can see here. Right, we got 2 2's for the length, 3 2's for the width. Multiply all together, we got 5 for the 2's, which is just 2 to the power 5. Right, 3 squared, same thing. It's 9. 3 times 3 times 3, which is 27. The area is exact same. Alright, we got 3 times 3 as the length, 3 times 3 times 3 as the width. Altogether is 243, which is 3 to the power 5 again. 4 to the power 1, of course, just 4. 4 to the power of 2, just 4 times 4, which is 16. Area of this is just 3/4 multiplied together, which is 64. Which, as we know, is just 4 cubed. Alright, so what do we do all this? Right, what patterns do we see here? Right, when we multiply all those together, right, when we just multiply the 2 squared and the 2 cubed, right, our result is 2 to the power 5. So whenever we multiply those together, we just add the exponents. Right, and you can see for 3 as well, right? 3 squared times 3 cubed. We expand it all out, we get 3 to the power 5. Right? Just exponents of 2 and 3, 2 plus 3. Next one, 4 to the power 1, 4 to the power of 2. Right, 4 plus 2 is 3. 4 to the power of 3. Right, pretty neat stuff. So now we can actually use this to calculate some harder questions. Right, 2 cubed and 2 squared. Once again, same as before. Right, we can now calculate this as adding the exponents up. 3 plus 2 is 5. 2 to the power of 5 is 32. So that kind of saves us a step in the middle where we don't have to actually calculate what's 2 cubed and 2 squared. We can just add the exponents up and then do the end. Right, next, right, we got 2 and 1. We can just add it up to get 3 cubed, which is 27. Right, it works for any number as long as the base is the same. Right, so remember, the base is whatever big number it is below the exponent. So right here, we got 2 and a 3. Add them up. Negative 3 to the power 5. Right, which is negative 243. And as you can imagine, division works the opposite way. Right, 2 to the power 6 divided by 2 to the power 2, which is 6 minus 2, which is 2 to the power 4, which is 16. We can visualize this too. So we got 2 times 2 times 2 times 2 times 2 times 2 divided by 2 times 2. Right, and as you can see, you can cancel. Those 2's cancel out, leaving us with 2 or 4 of the 2's. Right, which is 2 to the power 4. Right, so that's why division works too. We're literally just subtracting the exponents. So 4 to the power of 3 divided by 4 to the power of 2, just 4 to the power of 1, which is just 4. And of course, we can get some disgusting stuff like this. Of course, our calculators cannot handle 1002. But if we just subtract it, look at that. We just got 2. Negative 9 squared is 81. That's it. Alright, so that's why we use exponent laws. Alright, which means that when we have the same base, we add the exponents when we multiply. And when we have division, we just subtract. Right? So, very, very important here. It has to be the same base, like I mentioned before. So, as a note, let's say 3 to the power of 3 times 2 to the power of 10. Right, that does not equal to 3 to the power of 13. Right, because we got a 3 and a 2 here. Right? We cannot just add the exponents up if the two numbers are different. It always has to be the same. Okay? And yeah, the next page is just all practice on exponent laws. Oh, actually, before all this practice here, there's a few more to go over. So I jumped the gun there. Right, and what happens if we have exponent of exponent? Right, a squared to the power of 3. Right, so let's lay it out. A squared to the power of 3 is just a squared multiplied by itself 3 times. So a squared times a squared times a squared. And whenever we multiply, we are adding the exponents up, like we mentioned before. So we get 2 plus 2 plus 2. So a is to the power of 6. Right, so we actually notice something else here, right? Exponent of an exponent, instead of adding, like multiplication, we multiply. Right, 6 is 2 times 3. Right, we can look at our next one here. Right, for another example, we got negative b cubed squared. Right, so again, exponent of an exponent. That's the same thing as just 3 plus 3 because it's multiplication. So negative b to the power of 6. Right, and importantly though, negative b to the power of 6, we have a negative sign inside the bracket. And it is an even exponent. Right, which means that this will actually become positive b to the power of 6. Because remember, a negative number, a negative 1, to the power of an even exponent, all the negative signs will cancel out. And once again, we notice that it is just the exponents multiplied together. Right, how about this? CD squared. Right, it is just CD multiplied by itself twice. And we got two variables here. Right, so be careful about the bases. The C variable, right, has the power of 1 here and the power of 1 here. Because remember, if we don't have an exponent number, it's to the power of 1 by default, because we're lazy to write it out each time. D is exact same. And we got a D here and a D here. We multiply D and D together, it's D squared, same as C. Right, and we notice here that this exponent too applies to both of the exponents. Right, we got c to the power 1 and d to the power 1. There's 2 exponent here, applies to both of them. Right, so now they're both 1 times 2. Okay? How about this one here? So we got e times f 3 times. E times f, e, oops. This f doesn't look that good. E times f, e times f. Right, 3 times. As you can see here, we got 3 of the e's here. Multiplied together is just 1 plus 1 plus 1. Same as f. 1 plus 1 plus 1. Okay, so this is the same thing as e to the power of 3 and negative s to the power of 3. And because we know that we have a negative number to the power of an odd exponent is always going to be negative still, we can just move the negative sign to the front. Right, and once again, we notice here that the 3 apply to both of the variables here. Right, the 3 apply to the e and the negative f. Okay, how about fractions? Right, as you can imagine, exact same idea. This is just g to the power 4 over h 3 times. Right, so this is just g with 4 plus 4 plus 4. And then k with 2 plus 2 plus 2 because you're multiplying all of them. 4 plus 4 plus 4 is 12. 2 plus 2 plus 2 is 6. Right, and once again, we notice here that this exponent is just being multiplied to all the exponents inside. Alright, so the 12 up there is just 4 times 3 up here. Right, we got the 4 up here and the 3 over here. And then the 6 is h to the squared to the power of 3. Plus everything's out of the bracket. Right, and of course we can mix and match variables and coefficients. Right, so the first part, we can split them up. This is just 10 and 5 times the variables. Right, 10 over 5, which is just 10 divided by 5 is 2. 70, I to the 70 divided by I to the 68 is just 70 divided by 6, or minus 68. Right, it's just I squared. Right, and yeah, that's pretty much all there is to it with exponent laws. So with the new ones that we learned, if it's an exponent of an exponent, we multiply. Right, if there's an exponent outside the bracket, it applies to everything inside the bracket, even with fractions. And so again, this m applies to every variable inside. Could be multiple variables, as we'll see in the practice. Okay, so let's try a few here. Alright, so first, let's get all the multiplication here out of the way. And we got an k to the 8 times k to the 10. Right, again, no sign in the middle, just means to multiply. Always the case. So we got 8 plus 10 up here, k to the 5 remains the same. We get 18. And we got 5 at the bottom. Right, and then we will get k to the power of 13. Right, because we're now just subtracting 18 from the 5, or 518, because we're dividing. Alright, let's check the next one. So there's 2 here. 2 exponent applies to everything inside the bracket. So we get 4 squared. And then we get L to the power of 4 times 2. And then M to the power of 1 times 2, which is just 2. Alright, so 4 squared is 16. 8 times 2 is 8. M is squared. Just like that. And remember, this exponent only applies to what's inside the bracket, not outside. So the 2 actually just remains untouched. Right, the 2 remains untouched. The n and the p gets to the power of 3. Gets to be cubed. Okay, from here, once again, we got coefficients and variables. Generally, it's easy to split them up first. Right, I actually don't know why I decided to add some dots on some of them and no signs on some others. But remember, dots also just mean to multiply. Right? Multiply, there's a lot of things for multiply. We got multiplication sign, we got a dot, or we just have like two like there's no signs in the middle. Now, if you see a random sign, chances are it's probably multiply. Right, but anyways, we got q to the power of 9 up here. Right? Because we're adding the exponents up. Because they multiply. So that over, oops, wrong color. That over q to the power of 2. 15 divided by 3 is 5. And q is to the power of 7. Right? Because we got 9 minus 2 here. I got this variable, the 9 subtracted by the 2. Right, how about something like this? Right, we can add all the exponents that are multiplied together. So we got 3 plus 6 plus 9. What? 3 plus 6 plus 0. Which is 9. Over negative r to the power of negative 4. Alright, so now, what do we do here? Alright, we are still subtracting, right? Because we're dividing here. R to the power of 9 and R to the power of negative 4. So, all we're doing here is doing 9 minus negative 4. Which is 13. Oh. Which is 13. Right, because we're just dividing here. Right. The 9 divided by negative 4, which is just 9 subtracted by negative 4, which is 13. And of course, can't forget about the negative sign in front. I always remember the negative sign here. Because this doesn't just disappear. Right? Because we can think of this. We can really think of this fraction as r to the power of 9 divided by negative 1 times r to the power of negative 4. Right? So when this part is all undone, right? When this part is r to the power of negative 13, or r to the power of positive 13, we're still multiplying everything by negative 1. Hence why there's a negative sign here. Here's a fun extending question. I have a bunch of s's together. Right? But first step, we can actually take the negatives out, just so it's a little easier for us to figure out. Alright, negative s to the power of 5. Alright, negative s to the power of 5 will get us just negative. Right, we'll get a negative sign in front, right? Because it is a negative inside a bracket with an odd exponent. So we know the end result must be negative. Times s to the power of 5. And of course, we have the s, or the negative s at the bottom here. Right, and we notice here that this is just negative 1 times, oh, that's kind of confusing. S to the power of 5 looks just s and s. We can take the negative ones out, just like this. And we notice here that they actually cancel out. Right, the negative ones from both of those exponents actually gets cancelled out. So in reality, we're really just working with s to the power of 4 plus 5 plus 5. Right, this plus that. And at the bottom is s to the power of 1 and then 3. So all we have here is for s to the power of 14 over 4, or s to the power of 4. And then we just subtract them. Alright, just 14 minus 4. Alright, here's some really extending ones. Alright, so first up here, we make sure all the exponents go to their respective things inside the bracket. Right, so we got 5 to the power of 3, t to the power of 3, u to the power of -1 times 3. And then we got 2 to the power of 2, t to the power of 2 times 2, and then u to the power of 3 times 2. Right, let's multiply all the exponents out. 5 to the power of 3 is 125. T cubed is 2 cubed. U to the power of -1 times 3, which is -3. So all of this times 2 squared is 4. T to the power of 4, because it's 2 times 2. U to the power of 6, because it's 3 times 2. Okay, and next, right, we notice here, right, that 125 times the 4 is 600. I'll actually use the highlighter here, that might be a bit more clear. Alright, so 125 times 4 is 600. And then we got t to the power of 3 and a t to the power of 4. We add those up to get t to the power of 7. And lastly, u to the power of -3, u to the power of 6. We add them up, it's just 3. And voila. Right, so again, t is just 3 plus 4 here. Right, the 3 and the 4. And u is -3 plus 6. Ta-da! There we go. Last one. Ultra extending, if you will. First things first, make sure all the exponents outside the bracket gets into the bracket. So we got v with 2 times -2, w2 times -2, v2 times 3, w2 times 3. All of this over v1 and w. Oh, v-1 and w-2. We multiply all that out. V times to the power -4, w to the power -4, v to the power v to the power of 6, w to the power of 6. All of that over those two. We add the variables on top first. Oops. Because on top it's -4 plus 6 and -4 plus 6 for both of them. Okay, -4 and the 6. And for w, -4 and the 6. Add both of them up. Last step is subtracting. So we got a 2 minus a -1 for the v, and then a 2 minus a -2 for w. And then 2 minus a -2. And we get 3 and 4. Let me change the arrows here a little bit. 3 and 4. Alright, that's it, we're done. Right, just like that. So as you can see, some of those gets really complicated, but as long as we break it down into our 5 things. Right, when we multiply the exponents, we add. When we divide them, we subtract. When we take an exponent of an exponent, we multiply. And when we have an exponent outside the bracket, it applies to everything inside. Alright, that's all. Good luck practicing.